Hello, welcome back to this series. We are trying to write an operating system from scratch. Last time we've finished writing the first stage of our bootloader, and we finished it by loading the second stage from disk. But the thing is, we couldn't really try it. We can test it by running it on a virtual machine. And that is because we are still loading the first stage from a floppy, as we can see here in our boxrc file. The reason for that is we still haven't touched on anything that has to do with disk structure and partitioning and stuff like that. And if we want to load our operating system from a hard drive or something that can be emulated as a hard drive, we will have to actually go in and create a disk image for it. So that's what we are going to do today. So the game plan for today is create a disk image. First of all, we'll create an empty file that will be our disk image. Then we will partition it, and then we will write a utility to burn the bootloader to the first sector of the first partition, of the boot partition. All right, let's get to it. So what we need to do first is we will go into our build folder and we'll create a make file. Okay. All right. Okay, so this make file here, we will have a single target called image. Let's call it image. And the word we call it is make image. And basically what this will do is it will create our disk image. It will load every component we have for our operating system onto it, be it the bootloader's first and second stage and the kernel image, along with any other file we will have or need along the way. So, and so first of all, what we need to do is, as we've seen in our game plan, is create an empty file, an empty disk image file. And the way I want to do this is using dd. So let's just man into dd, and you can see that dd can be used to convert or copy a file, and that's exactly what we want to do. We have an example. No, but that's all right. Okay. Right. Okay. So here's what we are going to be doing. So here I can see a few things that we want to use. BS is the block size, and the count is the number of blocks we want to copy. So if we have a block size of 1000 and we copy it with a count of 10, it means we will have 10,000 bytes in our output file, right? So other things that are interesting is IF is the input file, so where we will be reading from, and OF is the output file. I guess these are all the things we will need. So let's just go back here, and we will call, of course, since we want an empty file, we will our input file will be just dev0, right? So dev0 just returns a bunch of zeros every time we read from it. And our output file will be something that we'll call, let's call it disk.amg. Okay, and now we need to decide how big this disk image will be. So let's go with something big enough for our future needs. Let's go for 10 megs. The way I'll do that is I will just compute. So 1 meg is so 124 multiplied by 124. So that's 1 meg in bytes. And the count will be 10. So that gives us 10 multiplied by 1 meg is 10 megs, right? So now we have this empty file, right? Called disk.image. And what we want to do at the very end of this build target is we want to move this disk image. So disk image, we want to move it to another folder just to keep things clean. And that folder, we'll call it, let's call it disk image, right? Of course, we need to go and create that folder. So disk, right, cool. So now what we need to do is, first of all, partition that disk. And there are a number of ways to do that, but the way I want to do it is using a utility called fdisk. And you know what, let's first try to do this manually in a console, just so we can see what we're working with. So what we want to do is, first I'll cd into build, and then I will run this dd command. And what you can see here is that it actually created a 10 meg file, right? If we ls into it, we can see that we have a disk image file. Yeah, so it's just a data file. It has no structure for now. We can fdisk our image. Sorry, but I want image. Oh yeah, it's called disk, right? Right, disk image, and this is what we'll have. Basically, we will have an interactive tool that will ask us questions, and given the answers we'll give it, it will do a partitioning for us. So let's start by typing M. M is for help, and here we can see that we have a number of commands that we can ask it to do. And now we have to make choices because we need to decide what kind of partition we will use for our drive. And the one I would like to use just to make our operating system, or actually to give us the chance to be able to use a UEFI bootloader in the future, if you want to, is that when you use a UEFI bootloader, you have to have your bootloader in a bootable partition that is of type GPT, right? So what I want to do is I want to get ahead of ourselves a bit and just make our first partition GPT partition. So what I will do is I will hit G, so create a new label partition, which will be GPT, right? So it created a new partition for us. And what I can do now is I can use the P command to print the partition, the partitions that we've created, right? P is for print the partition table. Right, so now I've created the partition, and what I can do next is I can hit new to create a new partition, right? The partition number, GPT is the partition table. It's the table that will list the partitions, right? Now we are creating a new partition, and this partition will be number 1. Of course, it's default, but let's hit 1. And its first sector will be, let's That's fine. I'm fine with the defaults here. And the last sector will be, let's just give it plus 10 megs, right? Value out of range. Why is it out of range? Right, okay, because we've already used a bit of our partition. Right, so let's just use all of it, right? All right, that's good. So what we want to do now is go ahead and print. And yeah, so now we can see that we still have a partition table that's of type GPT, and it contains a single partition that starts at this offset and ends at this offset, right? It has 80,000 sectors in it, which is about 9 megs. Right, so now let's see what else we will need to do. And that is, right, if you notice here, this is a Linux file system, and it's not really what we want, because we want the first partition to be, the partition table to be GPT, and the first partition to be of type FAT16. So here's what we will do. We will hit T for change partition type. This one here, change partition type. And then the partition we want to select. So it asks us to give it the partition type, or just hit all, L for list. And the one we want is this one, EFE system, right? So let's just give it one. Actually, no, hold on. We quit and give it one, right? So now if we print the partition table, you can see that it's of type EFE system, right? So now all we will need to do is commit this, because as of now, fdisk is working in memory, so nothing has yet been committed to our disk image. So what we want to do now is write this to our disk image using the W command. So write it, and there we go. So now if we look again at our disk image, we can see that it's a boot sector, and it has all the things we need, right? Okay, so now what do we need to do? Now we have our disk image. It has the correct partitioning, but there's nothing on it yet. And what we need to do is take a look at what our actual first sector looks like. So what I will use is hex dump. Give it the command N, so we only dump the first 512 bytes, because we have a 10 megabyte disk image. We don't want all of that. And then disk image, which is our file. And here you can see that we have just a bunch of zeros from the start and all the way up to 1C0, where we have our partition info. And then at the very end, we have the famous boot signature, which is AA55, right? And this is just before the end of the sector. So if you remember a bit what we've said that the bootloader loads the first sector and that we have 512 bytes of memory to write our first stage of the bootloader, right? But in actuality, we don't really have the full 512 bytes. We only have about 480 bytes, because the rest is used to write the partitioning scheme. Okay, so now that we know how our first sector looks like, or what our first sector looks like, what we can do is we can write a utility to basically copy our binary dump. So something like bootloader.bin, right? So what we need to do basically is copy all these bytes starting here, right? I'll go ahead and create a utils folder, because that's where all the stuff goes. Actually, I want to rename this. There you go. And in this utils folder, we'll create a C file called, let's call it something, let's call it makeboot.c. Okay. All right. So in this makeboot.c, what we need to do is very simple. So of course we need int main. We'll probably need some arguments. So arg count and char or car star, which is the argument values. And then, so what do we need to do here? So let's think about how we want to use this. So it'll be make boot, and then the first argument will be the disk image, right? And the second argument will be the boot loader that we want to burn onto it, right? So, okay, so we'll need at least, or not at least, we'll need 2 arguments. But since arg0 is the file name, that means that we will need 3 arguments, right? So if argument count is less than 3, we'll just let's just print something. We'll print that not enough arguments, not enough. Actually, let's print something useful, right? Usage make boot, and just copy over here. There we go. So let's just print this, and of course I'll need to bring in the print, include cdio.h, obviously. And of course we will need to just exit with some error code, right? And of course for exit we will need to include stdlib. Right, great. All right, good. So now let's get our file names, right? So let's start by making a car star, which will be the bootloader file name, and this will have to wait for a bit, and then here we'll just say, okay, we have enough arguments, so we know that file name is wait, which one was it? So it's, yeah, it's argument 2, right? So arg v of 2. Yeah. Okay. And what we need also is the we need the disk image also. So car star disk file name. And we'll set that here. Also, this file name will be argument value of 1. Right. So now what we need to do is start reading that file. And let's do a bit of tracing here. It will help us track any issues that we have. So let's write reading disk image, right? And of course we'll need to call it disk file descriptor, and we will use the open function to load the file. So the open function takes the file name, which will be the disk file name, and it also takes a flag to how we want to open that file name, and we are interested in opening it with only the read. So as a read only, basically, we don't want to write into it for now. Basically, what we want to do here is find our second stage so that we can write where it is and how big it is through the first bootloader, right? So let's write it as a read only. And of course, it will complain that we don't have open. So I need to go on and man open, and yeah, so we need sys types, sysstat, and fcntl. Oh, right, let's add those. So include fcntl.h. We also need to include sys stat and include sys what was it, types, I guess, right? And okay, and we will also need read. So let's look into that. So uni.std, right? So let's bring that in also. Include uni.std .h. Okay. All right. Okay. So now that we have the file open, what we will need to do next is go ahead and check. Of course, something we forgot to do is to define this file descriptor. So what did I call it? Disk fd, right? And we'll just define it as that. Do we need any other stuff here? I think we need another file descriptor for the bootloader, right? So bootloader file descriptor, that should be fine. So now, as is the case with any C program, we need to check that this is different from -1, otherwise it's an error. And if it is an error, we just need to print something, and error, let's just call it couldn't open disk image, right? And we will exit with some error code, say -2, for example. Should be fine, right? So now we have our disk open. So what we can do is we can actually read the disk. And what we want to do is let's actually create a buffer. So what we want is an unsigned car, and we'll call this data, right, for now. And this will have a size of 512. Actually, let's just call that sector size and go ahead and just define define sector size to be 512, right? That should be fine. Right, so now that we have that and we have a buffer where we can read to, we can actually start trying to read this file. So let's read from the disk FD, read from disk FD, and we want to read into data, and the size we want to read is basically sector size, right? Okay, if this is equal to -1, should be double equal, right? We basically have an issue, so we want to read disk image, and we'll just increment our error so that we can easily track where our program fails when we have an issue. Right, so now that we have this, we also need to, actually, before we panic, we forgot something very important to do. We need to close our file descriptor, right? Because we are going to exit. So until here, we didn't have it open. So now, starting now, we need to close it every time we have an issue. Right, so what we are going to do now is, so remember here, we've said that we have magic bytes. That's how we determine if we are on our second stage, right? Because the second stage will surely start with these 2 bytes. So what we will do here is pretty much the same thing. We will read from the disk image until we fall on the magic bytes we're trying to look for. And if we do, then we have the sector for the start sector for our bootloader, so we can use that, right? So let's have an int, and we'll call it second stage sector, and this I'll initialize it to -1, just so that we know if we've set it or not. And here what we are going to do is a for loop, and we'll go from, of course, we will need to also define a sector. We don't need to do that. So from sector starting at 0 all the way to, and here we need to define some limit. I mean, we have a 10 megabyte disk image, right? So technically we can just go through the full 10 megabyte. But that would be a bit too much, I guess. Actually, no, because we are very likely to find this early and break out of this for loop. So it doesn't really matter that we do this. The case where we'll go through the full, actually needs a 10x. The case where we'll go through the full 10x is the 10 megabytes, sorry, is when we didn't correctly add the second stage to our disk image. So as long as our second stage is on our disk image, we'll find it very soon, and we'll break out of this for loop very early. So it doesn't really matter. And let's do a bit of that. And then I will also add in, oops, sorry, there we go. Not read that. We want to do checking sector and that should be fine. Checking sector and give it the sector number. Right, checking sector and give it the sector number. And now what we need to do is start reading the sectors, right? What we need to do here is basically the same thing again. So if we read this and it's an error, we go through the motions again. Just increment this. So if so now we know that we've read the first sector into data, right? Or the sector we are currently checking into data here. So what we need to do is we need to check if data 0 is equal to our first magic byte, which is this one. So let's just do it this, and data 1 is equal to our other hold on, what was it? Yeah, 1c. Okay. So 0x1c. And if we do that, if we have these two, that means that we've matched the magic bytes. So what we need to do is just get this here and say that we found magic bytes at sector something like this, right? And of course here we need to write the sector. Is there anything else that we want to print? Actually, so what is this issue here? Oh, of course. Right, my bad. My bad. Right, so we have found the sector. So we need to print that we found the sector, and then we need to basically set the boot, what do they call that? Second stage sector is sec, and that means that we will just break out of this, right? All right, so let's break out of this loop. And the first thing we want to do after the loop is obviously to close our disk file descriptor, because we are done with that. We know where our second sector lies on the disk. So now we need to know. So one thing we don't know is how big the second sector is. And to know how big it is, we can basically use the same thing again, meaning we can put some other magic bytes at the end of the second sector, just to find them, measure out how big it is in sectors. But for now, let's not do that because it's not really a priority for us. So we want to open the boot sector, right? So that we can read the boot, not the boot sector, sorry, the bootloader, right? So let's, do we actually create a file descriptor? Bootloader fd, all right, cool. So bootloader fd equals open, and here we have bootloader file name, I think, yep. And we want to put it into some buffer. Do we actually need, can we actually reuse data? Actually, yeah, let's go ahead, since we'll still be reading the same size, which is sector size. So open it again. Just do the same check here. Here we go, and this would be 5. Open bootloader, of course, and this would be bootloader FD, right? Great. So now we have read the bootloader. We know that we've read the full bootloader, so we don't need to loop here because it's a maximum of sector size, right? So that's fine. And what we need to do now is we want to write the start address of our second stage to our bootloader, but we don't know. So let's just add this as a to-do, right? So to-do, write start address of second stage to bootloader loader. So what we'll basically have is something like a variable here that will be stage 2. Stage 2 start, and this here will be let's just do it something like actually it will be a double word, and it will be something like ff, right? And this value here is what we will be using for this here. So where was it? Oh, there it is. So this value here is what we'll be writing to this and this. It's a double word, so it's the same thing that we've taken, and we just need to move. Basically, do something like move. What's a register we don't need? I guess CX is not used. Yeah, CX is not used. So we move CX, the value of second or stage 2 start, right? And what we can do here is we can, so move this CX here, and then since we, so this will be a word, right? We'll be copying it in 2 halves, right? So this first word goes there, and then we move CX. Let's move into CX or actually let's increment CX by 2 so that we go to the address of the second half. So basically here CX will have, let's go here. Right, so CX will be somewhere here, right? It will point here, and it will copy a word, which is basically all the way to here, right? So this is the first word. So what we need to do is increment CX by 2, which will basically push the whole thing to 2 bytes, of course, which will push the whole thing here, and we will have the second word. Right, it's not really the cleanest thing we can do, and this is not the final thing we will have, but for now it's just a nicer way to think about this. But we will not be doing this for now, so let me just Ctrl-Z this whole thing and just leave the hard-coded values we've put in there. I'll just leave this value here. To do, write the start address on the bootloader. And now what we want to do is we want to open also at the same time our what was it? Disk file descriptor, right? Equals open disk file name. And we want to open it this time as a write only, right? So we want to write into it. We don't want to read from it anymore because we have all the info we want. And what we want to write into it is just these bytes, 480. Actually, not 480. It should be less than 1C0. So what's 1C0? 0x1C0. It's 448. It's not 180. It's 448. 448. So here need to write 16C0, which is equal to 448 bytes to the first sector of our disk, right? So we have opened the disk. Of course, we do the checks. Again, couldn't open. Actually, let me just not bother with this. I can just copy it from here. There we go. All right, so we're at 5. Just specify that we want to open it for writing here, so we know where we are in the execution. And then what we will need to do is we need to basically copy it from data, right? This data here, we have the full bootloader on it. So we need to copy this amount of bytes to data. So what we need to do is basically if write, so let's write, okay, can't type, write, what was it called? So disk fd, right? And what we want to copy from is data. And what we want, the number of bits we want to copy is, so 1x 1co minus 1. Actually, let's copy the full 1x 1co. And here, if this gives us a, so basically write returns the number of bytes written, and we want this to be equal to this. So if it's not equal to that, if it's less, actually, if it's less or equal to 1x 1co, then we have an issue. That means that we can write the whole thing. So printf, right, so printf, what do we want to printf here? We want to do couldn't write bootloader, right? And I think we are pretty much done here. Of course, we need to exit with some sort of error. Close disk fd. Did we close the bootloader? No, we did not. I think we don't need it anymore, so we can go ahead and close the bootloader file descriptor here because we've loaded everything we need to data, right? So on error, the write returns negative value, but we'll just consider that if we couldn't write all of our bytes, that is an error in itself. So just go ahead and do that. Right. So now that we have written this, we can go ahead and close the disk file descriptor again, disk fd. We can close it, and then we can just say that everything went swimmingly. Yeah, printf, and just say bootloader installed, and second stage starts at LBA. What was it? Hold on, did we save it? Oh yeah, okay, we saved it. Second stage sector. Right, so second stage sector. Great. And that should be fine, I guess. Yep, that should be fine. So one thing we need to do now is add a small make file here. And this make file here will be used to build our util folder. We'll just make it simple. So let's call it utils. This might be confusing, but yeah. What we'll do is clang O, and actually we'll need to define. Actually, let me just copy it from somewhere. Where did we put it? Yeah, there we go. So just copy this this output there here. We'll build so make boot, and the file is makeboot.c, right? And that's it, I guess. And then we can, oh yeah, actually no, let me just add the important stuff. So we want to move the make boot to output directory. So let me just copy that also. Right, let me just do something like this. And what we can do is we can do something like so, and give it make boot, right? We will probably also, should be fine. Okay, should be fine. So let's rm, let's remove, let's force it, I guess. This thing here, in case we want to clean, and that should be fine, I guess. So now if we go to our global make file, we'd want to add another target here. That will be make -c utils. There might be some confusion here because we've called the target utils utilities. There we go. That should be utilities. Right, that should clear all confusion. And now we can also build utils. And what we want to do also is we want to add this make file to our global make file, right? So what we want to do is build, and this will go make -c build, and what was it called? Image, right? Build image. And of course, this will be the very final thing we need to do. So should be fine. Right, so what we need to do now is we need to go back to this build make file here, and we need to add the step we've just created, basically installing the bootloader to our disk image. So what we need to do is call make boot, like so. And what was, yeah, the first argument would be the disk image, and then the second argument would be the bootloader binary, right? I think that's about right. Let's also add a clean target here, just so that we can use it. So what do we need to do? We need to so we need to remove this, right? Okay, let's test it out. Let's make wait. Oh, of course. Okay. Let's cd out of the build directory and go ahead and to make all. Of course, it will say that I need to force it, otherwise it will not like it. Okay. Okay, we have an issue, but the okay, so incompatible pointer to integer teacher. Oh, right. Okay, my bad. That was very dumb of me. So the second time we open this, of course, we've opened it, but we still haven't read it, right? So we need to read it. Right, so let's read the bootloader file descriptor, right, to data with sector size. And of course, this here, we just need to be read only, right? And that should be fine. I guess we just need to add an if statement here, just to ensure that this is different from -1. And yeah, we'll actually, we don't need to do that. We actually need to check if it's equal to -1. We'll print an error message, and then we'll print an error message and can read bootloader file, right? And what I'll need to do is actually I'll need to add a carriage return in all the printfs so that the console output is cleaner. Right. It's weird that the C compiler only gave us yeah, hold on, there's a typo here also. The C compiler only gave us a warning when we called the open with bad arguments. So what we need to do for that is we need to enable all warnings, I guess. So what was it? Was W W all or something? Let me just Google it quickly. So Clang warnings. So it should be W all, and there is another one that basically goes an extra mile into ensuring that we don't have any weird conversions. Is it this one? Yeah, it's W. So W all and W extra is what we need. So W all, W extra. Right, let's redo this. So make clean. Oh, that's something else we forgot. Right, we need to actually do the clean the clean targets here. And the way we are going to do that is basically just go into every single one of these and just clean it. Yeah. Right, so let's do it like so, and do it like so. And this would be clean, and this would be clean. Is there any reason we've called this all? Shouldn't we have just called it bootloader? It's weird. Right, this should be fine, right? And now we, oh, okay. I see why we did that, because it'll be confusing with the file name. So yeah, let me just send that back. Just put that back. It should be fine, right? Okay, so let's make clean again. Yeah, wait, there's an error. No rules to make target clean for utils. Okay, weird, but okay. Oh, yeah, okay. Fine. Right, let's make it clean. All right, no errors, fine. Great. Make -b all. Okay, so we still have an error. Reading disk image couldn't open disk image. And why is that? It's not permissions, I think. Right, let's add a few things here. Let's do reading this image, something like this, and disk file name, right? And now let's just copy this here. Yeah, let's put this reading bootloader, and this would be bootloader file name. Right. Okay, let's try this again. So let's do it again. Disk EMG. Huh. That's very weird. That's very, very weird. Well, actually, there's something else that we're missing here, because we still haven't partitioned our disk. We have cleaned it, we have recreated it, but we haven't partitioned it yet. We haven't written the command to partition it. And since fdisk is a interactive tool, we need to find a way to basically stream what we want to type in as an answer to every question into it. And the way we can do that is we can use printf in the shell environment. This will take a string, and we can pipe that string into fdisk of disk image, right? So now the question is what this string would need to be. And to find that out, I guess we need to rerun fdisk build disk image, right? So first thing we want to type in is G, right, to create a partition table. So we type in G and a new line. Let's do that, G new line. And then what we want to do is we want to create a new partition. So we want to create a new partition. So that would be new partition. The partition number would be 1. All right, so that's first new partition, and of course send in the return key, and then the partition number would be 1 with the return key. Oh yeah, I need to do that. So 1 return key, and the first sector would be 248, of course, with the return key, 248 return. The last sector would just be, so we know that we can't have the 10 megs because we've used 2 sectors from the 10 megs, so we can at least have 9 megs maybe? Value out of range. So maybe 8 megs? Yeah, 8 megs is fine. So let's print in 8 megs with a return. And then what we want to do is we want to change. So now if we look at what we've done, we have created a new partition of size 8 megs. This step we need to do now is change its type to EFI system, right? To do that, we need to hit T, and then I think it's 1 that we need to type afterwards. Yep, so it's T and then 1. So here, let's hit T, carriage return, and then 1 carriage return, and right. So now if we reprint it, we have everything that we need. We have everything that we need, so we just need to write it to disk, and we write it by using W carriage return. And of course, W, enter, and that should be fine, right? So now if we do make clean, we delete everything, and then we do make be all. So syncing disks, changing file system. Right, so it's working. We have created a disk partition that is of the correct type. Okay, well, after a bit of troubleshooting, I found out that the condition we were checking was actually wrong. We were checking that the file was actually opened correctly, and we were throwing an error. So we need to go on, and since I did a bunch of copying of these things, I guess the error is a bit everywhere. So yeah, that should be fine now. Yep, that should be fine. So let's go again. Make clean and make -b all. Okay, so that's fine. So we can see that it's checking all the sectors. The issue being that the file is actually not being read anymore, because we are checking 10 megs and the file should only be 10 megs. And it should only have, just put this here, 10x 10x 124, 124. If we divide that by a sector size, we only get about 20k for 80 sectors, right? And we can see that it went way beyond the read function. System call will actually return negative values and positive values, which are the number of bytes read. So what we need to do is we need to check that this is less than 0, right? And we need to probably check that. So let me just go back to Google this. And here we can see number of bytes read is returned, 0 indicates end of file. Right. What we need to do now is go and fix this. So if this is equal to -1, right? So just keep this in. Otherwise, let me just put this on a separate variable. Let's call it int read bytes. There we go. Right. So read bytes equals that, and if read bytes is -1, we have basically errored. Otherwise, if the read bytes, what's happening here? Yep. If the read bytes is 0, means that we've reached the end of file, and we still haven't found the magic bytes. So what we need to do is we need to, instead of doing this, actually we need to probably do something like this, and instead of couldn't read, say couldn't find magic bytes, right? And the rest should be fine, I think. So let's go again. Right, does it stop when it reaches 20k? Yes, it does. Couldn't find magic bytes. Great, great, very cool. We will try to create a fake second sector. Just write a few bytes to a file and have the makeboot try to use that as a second sector. So we'll sit into build, clear this, and we'll use echo to basically write bytes to a file, and we'll call that file second stage, right? So the bytes we're expecting, the magic bytes, are where are they? FA or F4, and then X1 C, and we can output those to second dot bin, right? Now, if we hex dump second dot bin, we have the 2 bytes that we are looking for. So let's just try to do something else, right? Let's try to do something, and then hello world, and we'll put it into that same second dot bin, and actually just overwrite it. Right, so now we have 1C, F4, and we have our file contents. Cool, great. So this is our second stage. So now we need to put this second stage onto the disk. So let me just LO setup. So we have this tool here called LO setup, which is a setup to basically admin loopback devices or loop devices. And with this, what we can do is we can actually mount a file as a drive, as a device, and then we can do a bunch of stuff on that device, right? Okay, so let's try to do that. Just go ahead and do LO setup disk image, and it will load it for me as a loop device. But I also want to give it the F command, which is to basically find the first unused loop device. Usually that would be loop 0 unless you have other loop devices in use, but in my case I don't, so I know it will be loop 0. That means I can in my build script I can just use loop 0 and hardcode it there. I don't need to check where it was mounted, right? Okay, so what I want to do also is I want to skip a bit of the disk so that we don't retouch the first sector. So let me just skip a bit. Let's skip 5 and 12. I guess that's it. Let's check it. So let's create a file system by making make file system .vfat, and we'll let it know that the fat size needs to be 16. We'll also go ahead and give it a name, and this name would be let's just call it EFI system, since it's the name we have given to the partition. So, and now we have to give it the device, so it should be loop 0, right? Right. Okay, so what does it say? Loop 0 has 2 heads, blah, blah, blah. Yep, that's fine, that's fine, that's fine. Okay, all right. So now what we can do is we can actually mount this this disk we've created as a folder on our system. So what I'll do is I will make a directory. I will call image. Yeah, let's call it image. And then I will mount. I need to specify the type. It's vfat and fat16. Actually, it's this way. I need to give it the device, which is loop 0. And the device should be mounted to image, right? Yeah, mount. I can see that loop 0 is mounted to the image folder. Cool. So now we have our drive as a device, loop 0, and then we have our device mounted as a folder on our file system hierarchy. So now we can copy stuff into it and we can actually do whatever we want. So first of all, we will try to make things nice. So make dir. Let's start to make all the parents. Actually, let me cd into image first. Right, makes things easier. So make dir. Do make all the parents, and I'll call this BIOS boot, right? So now if I ls this, I have BIOS boot, and what I can do now is I can copy the second, oh yeah, of course. So let me cd out of there. I can copy second.bin to image, BIOS, and boot, right? And I can call it stage2.bin, for example. Right, so now if I ls image, BIOS boot, you can see that we have stage 2 in there. Great. Now what we need to do is we need to unmount it. And to do that, we use umount image. We can actually go ahead and rmdir that image folder. We don't need it anymore. Let's put everything together now. So let's go and do low setup. O and F, find the first unused one, which is in my case loop 0, and give it the file image. And actually, there's something that I need to do, and that's I need to make sure that since I want this to be the first one to always be loop 0, what I need to do is I need to detach all the other loop devices, including my own if it's already attached, right? So LO setup dash capital D does a detach for all the loopback devices. We make file system, and what was it? vfat, and we tell it that the fat size should be 16. Give it a name. We said VFE system. It could be anything actually, we don't really care. And of course we need to tell it that our device is on loop 0. Then we need to basically, so we create a directory where to mount it, right? And then we mount it to that directory, right? So T type is vfat with fat bin 16. And then, so our device, loop 0, and the folder is image. And of course here we can just go and remove that image folder in reverse order, and you mount, just unmount the image, right? Okay, so what we need to do now is create the folder where we will put our second stage, right? So let's call it BIOS boot, and now we can copy second.bin to image BIOS boot stage 2.bin. Right. I guess that's about it for this. Okay. I think we're getting closer. We are about to run our operating system from a hard drive, which is great. So let's do make clean, right? Make -b all. Of course, great. So make clean again, make -b all. There we go. No such file or directory. Oh, okay, shit. My bad. Actually, this needs to go here also. Yep, my bad. Yep. So let me just delete this BIOS directory, delete this image directory, and actually, let's go again. All right. So clean make all. There we go. Contains a mounted file system. Right. So if I do a mount, I can see that this image is still mounted. So we will probably need to add some steps in the clean to unmount the right. There we go. So now if I go ahead and do mount, it's not there anymore. And if I go ahead and do LO setup, it's not there anymore. So we are good to go. So again, make clean. Great. Make -b all. Right. Could not write bootloader for some reason. So we found it. We found magic bytes, which is great news. But now we cannot write the bootloader for some reason. So couldn't write the bootloader. Oh, I see. Yeah, actually, you know what? Let's just say that if this is inferior or equal to 0, we'll say we couldn't write it for now. Just for now, right? Let's make things easier for ourselves. So let's make clean again and make dash b all. Right, great. That's great. Okay, so to end this video, let's attempt to run our disk from a drive, and that drive would be in disk.emg. Right. Okay, fingers crossed, and let's run box. Right, and why is that? So basically it says could not open hard drive image for some reason. Okay, so after a bit of fiddling, I found what the issue was. The issue was that low setup was still had still the control of our disk image, so that's why we couldn't load it in box. So what we need to do is we need to add this low setup dash capital D to detach the disk after we've finished everything that we need to do, and that should be a lot better now. So if we go ahead and call box and run it now, no bootable device. Okay, that's not good. So let's give it a bootable device then. I wonder if our disk image still has the boot signature. So let's take a look into it, right? So hex dump n would be 512, and it will be dist. Yeah, well, actually, it's not there. So hex dump with n 512, and it'll be dist disk image, right? Yeah, so we still have the boot signature, but it's ignoring it for some reason. That's fine. Let's just tell it to boot from the first drive. Okay, so all right, great. So now we are booting. The drive is mounted, but we still have an error on the first stage of the bootloader, which is couldn't read sector from drive. Right, and I wonder if that's because we have inverted the sectors. Let's try to do it this way. Maybe the sectors were actually incorrect in the NS order. We just inverted them. So let's go ahead and redo it and call box. Okay, so sector doesn't start with the expected magic bytes. So we've read the sector. It does not start with the expected magic bytes. And let's see why that is. Let's see what we are seeing when we read the sector. So what we are going to do is we are going to, so where we have this here, bad magic, and this read success is where we need to put our breakpoint. So what we need to do is, first of all, I'll just obj dump that. So Intel -M I 8086. With it being a binary file, we want to disassemble it, and we want to do that for build and bootloader.bin. Right. Great. So let's try to find. So here we are reading the, and of course there's something we forgot, that something that's very important for us, and that is to actually adjust the VMA to be the address where will actually be loaded. So 7C00. That will make it easier for us to just copy the address where we will need to put our breakpoint. So here we have our packet initialization, and then we do call interruption 13 with the 42H. So that's something like so. And then if we have successfully read the sector, we just jump to this. So we jump to 7C75, and that's here. And that's where we want to put our breakpoint. So just copy this. Let me just use my keyboard for this. Right, so just copy this and use box debug, of course, with the magic byte option. That means that the box will basically stop as soon as the bootloader starts executing. The BIOS starts executing, and we can put our breakpoint. So I'm putting breakpoint B at 0x, and the address I've copied. blist to ensure that it's there. It's fine. So let's continue. All right, great. So now we are at the instruction. We know that as of now, we have read the first sector to address 800. So what we are going to do is we are going to dump what we have at address 800. XW, and we want address 800, right? Let's try something else. Okay. So did we actually read something? It seems to me that we did not read the correct thing. Right, let's read a few of these. Let's read 20 bytes. Okay. Yeah, we did not read the correct stuff. We can hex dump our disk image, and we can hex dump it starting at a certain offset. I think it's O or skip. Okay, it might be skip. So we want to skip 88 sectors worth of sector size. So that would be 88 multiplied by 512. That's is this many bytes we want to skip, right? Let's go a bit back and dump a few more bytes. Let's try to dump a few more. Right. So, okay. It seems like we are not aligned to a sector, or at least Oh. Huh. Okay, hold on. If I do this, go here and do something like so. Oh, okay. No, we actually are aligned to a sector. We're just not on the 88th sector. We are on the 89th sector. So let's fix that. Should be 89. And we will rebuild this whole thing. Clean. Of course, it's permission denied. I need to stop box. All right, I need to try to quit. That's fine. And now I need to rebuild the whole thing. Make all B. Right, so let's start it again. This time just with box. Hard drive does not support. What? Okay, so I think we need to correct a few things. So first of all, this thing here that we did for offset and segment, actually it was wrong because segment should come before the offset as well as the sectors. So this here would need to be sector 89 because that's where we're writing the second stage. Also did something else. I've stopped using a segment, so I've used directly put the address into the offset. So let's retry it. Let's relaunch box debug and start it. And of course, I'll put our breakpoint at address 7C75 if I remember correctly. And yeah, okay. Let's do a few checks first. So let's see what we have in the LBA packet. That's fine. If we take a look at our registers, we can see that AL is 0, which means that it went fine. And if we take a look at 0800, you can see that we actually have our content now instead of just zeros because we are reading the correct sector. Right, so let's try to step into these things. So now we are moving the first word here into CX. And then now we're attempting to compare BX and CX. So let's first take a look at what we have in BX and CX. And you can see that BX is this, CX is this, and we should be fine. So compare, jump if not 0, should be fine. And now what we will do is we will try to find the first instruction, which would be the word after the magic bytes, and put in AX. So if we take a look at it, we can see that AX should have 802. So if we follow the jump, you can see that we are at 802 and the first instruction is 48. And if we look at what we have here, you can see it's 48, 856. Of course, these are not real instructions. This is just text that we've wrote. This is hello world after the magic bytes. But at least it means that if we have meaningful instructions here, we will be able to execute them. I guess that's it for today. Next time we will start working on a second stage. So until then, take care. Bye.